Hello and welcome back to Compiler Programming. In the last video I started working on the floating point support, and in between the videos I also added basic support for 64-bit floats, that didn't require literally any changes. I just needed to have a bigger size of the register and different encoding for the instruction. But those are super basic changes, so you can check it out on GitHub. And today I want to start with this part. So this is super ugly and unnecessary, but I wanted to make some progress in the last video. So I just pretended that our floats are actually integers, so we could put them on the stack. So let's do this part first, and I want to have something like value from F32, and I would say 420F, right? And that should be working somehow. Well, the first thing is we do not have a float type, and I think similar to integers, we will internally probably store floats as for immediates and such as doubles, and then scale them down. So there will be only one float type, I guess. But we'll see if I also want a separate double type. But for now, let's go with one. So we have float, right? And then we should have basically similar to integer. We would say descriptor float, and you would have byte size, and this is what we will deal with here. So descriptor float, and we would say, I guess it will be float underscore, similar to struct underscore, because we cannot use keywords as names of the fields in structs. Okay. That is done. We need to have a descriptor, I would guess. So let's add that. We'll copy this S32 and S64 and just replace float here and say that this is now a float as well. And I guess we need to do the same thing with the actual types that we are using for parser. So there will be F and the same thing here. Might make this into a macro at some point, but for now that is fine. Let me think if we need something else here. I don't really think so. Okay, so this is our parser, and it tries to figure out the type of the return value. So here's the C type, and well, okay, this is actually interesting, and for now I will just say that it's not implemented. So because we don't really have support for, like, I don't remember how we return floats. I think we return them in XMM0, but for now I'll just say that this is to do. So assert net to do. Okay. What else do we need to deal with? This is descriptor byte size, and it's actually exactly the same as with integers. We just say float and float here. So nothing complicated about that. And finally, it is checking for the type. Again, I think it will be the same as with integers, where we are just checking their byte sizes. Right? That seems good. Yep. Okay. Move value. Oh, that is interesting. Okay, so value from S32 is what we don't have. So there is value from S64 and value from S32. Now I can create ones for the float as well. So we say F64 value, and then okay, maybe call it draw. And now we need an operand. And this is where it becomes quite tricky, because the problem with floats is that we cannot really encode immediates. Like, they just do not have that capability. Let me show you. So if we go into Compiler Explorer and we look at how this expression would be encoded, then you would see what is happening. So instead of, because there are no immediates in the instructions, we actually have to put this into the global data and then reference that global data in our program. And this is sort of interesting thing to consider how we're gonna do, right? Okay, how does our test look like? So this is what everything else is doing, and so the thing is, we could put it on the stack and then we just do basically what I'm doing here. We encode it as bytes and move it to the right position. That is an interesting thing to consider. First of all, this will be just stack, not stack S32, I guess. And then I don't know how to best make it with macro, or if I want to support macro form of this at all. So I guess let's for now make an unoptimized version of that, where we would have to pass the program to value from F32, because it will need to put it as set in a global data, and then we will just copy that from global data to here. It's not very nice, but for now I'm not really worried about performance, so let's keep it that way. Okay, so how do we do this? I will first do the F32 version, I guess, because that's what we are working on right now. And let's see. So descriptor is this. Descriptor is F32, and then as far as operand goes, we would have to put it in the global data, and I think I have it somewhere. Global, yeah, we have value global. So this is something to consider. Let's check that we can call it from anywhere. We cannot, but I could do this. Okay. So we have value global. We pass it the program, we pass it the descriptor, and it gives us a value with this descriptor. Okay, that seems like what we want to do. address. And I will copy this because this is how we are. Basically, this is what we will need to do, more or less. Obviously not with a string, but with this stuff. We don't need to allocate descriptor, like that's not a thing. Here we will need to, of course, have f32 and raw float, or maybe, why can't I find letter L? This is crazy. Float value, and we also pass program. Okay, so we create a value for descriptor s32. I might need to do that. Then we get the memory. Here actually we can just cast it to f32 star, and instead of memcopy we can simply say star memory is float value, and then we return result. So something like that. Okay. We also don't have read value pointer. I guess let's take all of these. Whatever. We can also add read value pointer to our header. That's okay. Good. Let's open up function.h to see what defines stack. Okay, the first ID, then descriptor, then value. Okay, so ID is this f32, then we would have descriptor f32, and then we have value. Okay, that builds, but I believe it will be unhappy when we try to encode the move, because if you look at what stack does, it reserves a stack for this, and this should work just fine because it just gets the byte size, and byte size we know for the value, but then move is not something that supports floats at the moment, so it will have issues, at least I think so. Okay, it did not. So let's look at what is that all about. I mean, technically, if we have two memory values and they are, if we have two memory values and they are the same size, then move doesn't really care that they are floats, because then it all just bytes. It is when one of the sides is not memory, whether it is a register, then it becomes a problem. So that might even work as it is now. So let's still open up function, and then we have move value, and move value. Okay, so yeah, right now it just checks that, yeah, this is pretty bad and not what we want to have. So let's start adding more type checking. So first thing is let me think about how to make that happen. Maybe that's actually okay. Yeah, this is completely not ready to deal with floats. So maybe what I will do, if I say target descriptor type is descriptor type float, or source is float, source float, then we should be doing something special, I guess. I mean, again, if both of them are memory, then everything is fine. But first of all, we should check that they have the same size. So I'll just say assert, and this we can move here. And I would say descriptor size is source size. Then we would say that if target operand type is operand type XML or something, operand type, yeah, operand type XML, whoops. So like this, or sources XML, then we for now don't know what to do about that. So I'll just say assert to do. Otherwise, I'm asserting that both of them are memory. Operand type is operand type memory indirect, and source operand type is memory indirect. And if that is the case, fall through and treat them as integer, as bytes to be moved around. Something like that. Okay, let's see what that will yield. So assertion failed that source operand is memory indirect. That is interesting. Oh, yeah, I should be using a different check. I should be saying that operand is memory, because there is also rep relative, which I think I should be turning into just regular stuff, but we'll see. Source. Okay. So now that's more interesting. What does operand is memory do exactly? Yeah, that seems pretty fine. Okay, let's open up debugger and see what the type actually is. Who? Not responding. Okay. Let's just run this. Yep. I want this move value. I want locals, and I want to look at the source and the target. So what is going on? So we are in, oh, we are in nested, yeah. How do I want to deal with this stuff? So what's going on is, let me open this. Yeah, we go to here and then we fall into this branch and we realize, oh, actually they are both memory, which is what we want. But here we go again into the move value and we end up here and we check, okay, one of them is actually not like, they're both floats, but one of them is this stuff, so we have an issue. How do we deal with that? Well, I guess what I can do is, in this case, I will just again pretend that they are integers. So I will say values, they're like float bytes is operand is target float bytes, operand is target operand, and as far as descriptor goes, we are just pretending it is an integer. So this will be descriptor type is descriptor how do I do this? Descriptor type integer, and integer byte size is target descriptor float byte size, something like that. Okay, good. And basically the same thing for the source, except obviously we use source byte size and source operand, and we recursively do now move value of builder targets float bytes source float bytes. Return anything, so just do this. Okay, now that should be better, I think. Let's try. Okay, that is very, very good. I'm kind of okay with that. Not sure if this is the best way to deal with that, but at least it works. So we have episode 103, support, stack allocated, F32 values. Okay, let's make that work for 64-bit ones as well, which will be just a bit more copy pasting, which again maybe at some point will be condensed together back into something nicer, but for now that's not an issue. Test of 64, we're removing this F. Okay, this looks good now. We can take this thing. Here should be F32. Oops. And then F64. 64, 64, 64. Sounds good. Let's check if that works. Okay, that does work, which makes me pretty happy. And I do want to see though how it looks like in assembly, that to check if everything is okay with how we are approaching this. So let's step inside and look at what's going on. So we are moving some pointer that really doesn't matter what the value is as long as it makes some sense. And then we are moving it to the we're moving to stack. So that's fine, that's just this double move. And then we have move them. Yeah, that all sounds fine to me. Next step would be to commit this. Episode 103, support F64 values on the stack. And I guess next one is a tricky one where we would return an F64 or F32 value. So let's do that. Okay, how does that work? I will comment this out for now. And I guess we don't need it on the stack, so this will be how do I want to do it? I guess let's create a new test, and you would say you should be able to return an F32 value. And then we would just take that, we would put it over here, and we would need a new function type, obviously, and then we have this, and this is where we would have a bit of an issue. I mean, for the return, I should be able to do exact comparison because it literally needs to be byte for byte correct. But if we do any operations on them, then it becomes a bit trickier. But for now, this is okay, I believe. Cool. So here we would need to have F and F. That should be building, I guess. Yeah, here. Cool. But we don't know how to return them. So I will not even try that because I know it's gonna be completely not what we want to do. Return. Okay. This seems fine. We need the function descriptor, so when we are creating the function, we need to do stuff, I guess. Where is this happening? It is here. Function return descriptor. Yeah, it's actually this thing that is that needs to know about this stuff. So I'm going to say if descriptor type is descriptor type float, then we do something, otherwise we do something else. In reality, we can add a to-do here. I think like handle 16-bit return values that are also returned in XMM, maybe. Let's go check. So x64 calling convention, yay. Yeah, so floating point arguments are passed in XML, blah, blah, blah. And what about return values? Wait. So M128 are not passed. So these are the passing varargs are return values. Yes. Scalar are in memory. 128. Yeah, this is what we need to support. So this is what we need to do. Passed returned in XMM0 in non-float. Okay. For floats though, we need to do what? Well, so this is definitely XMM0, and we might be even able to reuse this function, maybe. What do you do? Yeah. So type is gonna be tricky. We can say operand type, operand type is descriptor type is descriptor type float, then what? So if it is a float, then we would have operand type XMM, otherwise it is operand type register. I'm starting to think that the way I model this is not the best way, but this is my first attempt on floats, so we'll see if that is good or not once we have better functionality. So this should work now. We can there are also not 1 or 2 bytes of floats, but whatever, that's I guess is fine. And yeah, we say we will return it in XMM, and then we are just gonna move value. So this is where we would come back to the problem of let's go to the actual thing. I guess it's here. Yeah. Okay, we have move value and we should assert now on this to do, I hope. Let's try that. Yep. So we are here and well, how do we do this? Basically, if one of them is XMM, then we need to check that the other one is either XMM or memory. So let's say that if target is XMM, I mean, encoder will also check that. So I guess let's just do this. If target size is 4, else if target size is 8, else assert not reached. So this is basically if we get here, it is something that I did not expect to happen at all. So I'm not expecting to support 128-bit floats anytime soon. So that's going to be a long time before we get here, I hope. There is also 16-bit floats in some platforms, but let's just ignore those for now as well. Okay, so we got to here, and that means that we would use move SS, or we would use a move SD. Now that I'm thinking about it, I might not even need to do this anymore because I will just go through XMM value, and that might be better because it will reduce pressure later on other registers. Okay, let's see. Okay, so move SS, then we say target operand and source operand, and if this is here, it's basically the same, just we use move SD. Think that is what I want. Yep, that looks good. Oh, let's try that out. Okay. That did not seem to be working like I would want it to work. And that is because I think I'm not doing the right thing in encoding, maybe. So, okay, we have XMM and then we have REAP. Yeah. So this should be also operand type REAP relative. Okay, let's try it again. Wait, why are you trying to do a move? I know why I tried to do a move, because I forgot to return here. Okay, that actually looks really good. Again, let's quickly check out how it looks like in assembly. And that would probably be it for now. Let's see. So F5, disassembly, we go inside the call, and we are doing absolutely useless sub and add, which is also something that can be optimized away. But here we will just get this stuff out and go back, and everything should be fine. We can now even look at the result, and the result is 42, just like we wanted. Okay, I guess that would be all for today. I think this is pretty nice progress. I might try to play around with this part a bit and clean up things, but now we have F32 and F64 actual types that we can deal with. We can return it from the function, and this is pretty neat. Thank you very much for watching, and hopefully see you next time.